Chapter 2, Equations, Inequalities and Absolute Values. 2.2, Inequalities. The learning outcomes of this unit, students are able to solve rational inequalities involving linear expression. So what are rational inequalities? Inequalities that can be expressed in the form of Px divided by Qx and using whatever inequality sign, meaning it is a fraction. Examples of rational inequalities are like 3x plus 1 over x minus 5 is greater than or equal to 2, and so on. When solving rational inequalities, make sure that do not use cross multiplication. This is because we do not know the sign of the algebraic expression. Then we gather all the terms to one side of the inequality and solve by using any suitable method. Look at example number 1. We are going to use the number line method to solve this inequality. 3x plus 1 over x minus 3 is greater than 2. So remember, do not cross multiply. We gather all the terms on the left by bringing 2 over to the left hand side. We simplify. The common denominator is x minus 3. And lastly, we have x plus 7 divided by x minus 3 is greater than 0. Now, for the number line method, we have to consider all positive factors. X plus 7 is greater than 0 and x minus 3 is greater than 0. So we have x is greater than negative 7 and x is greater than 3. So you draw the number line, negative 7 and 3, and x is greater than negative 7 is denoted by a solid line which is positive, and then the tail is negative denoted by dotted line. For x greater than 3, solid line, and x less than 3 is dotted line representing negative sign. So for the 3 intervals, negative divided by negative is positive, positive divided by negative is negative, and then positive divided by positive is positive. So since the inequality symbol is greater than 0, the intervals with positive signs are selected. Therefore, the solution will be negative infinity to negative 7, union 3 to infinity. So the solution can be in interval or set notation. Let us look at number 2. We are going to use the number line method again. Solve x squared minus 6x plus 9 divided by x minus 7 is greater than or equals to 0. So we factorize the quadratic expression and we simplify x minus 3 squared divided by x minus 7 is greater than or equals to 0. For the number line method, as usual, we are going to consider all positive factors. So for x minus 3 squared greater than or equal to 0, x can take all numbers on the real number line. Take note that although the inequality symbol is greater than or equal, x cannot be equal to 7 as the factor x minus 7 is at the denominator. So when x equals to 7, the rational expression is undefined. So the number line is drawn, 3 and 7. So for x equals to any number on the number line is denoted by a solid line. For x greater than 7 is represented by a solid line and the tail is dotted line. So for the interval less than 3, positive divided by negative is negative. From 3 to 7, positive divided by negative is negative. For x greater than 7, positive divided by positive is positive. Since the inequality symbol is greater than, the interval with positive sign is selected. So the solution in the interval form will be 3 union 7 to infinity. Take note that 3 is a solution as it satisfies the inequality greater than or equal to 0. Example number 3. Solve 3 over x plus 1 is greater than or equal to 1 over x minus 2. So gather all the terms on the left, simplify 2x minus 7 over x plus 1, x minus 2 is greater than or equals to 0. Let us consider all positive factors. So when 2x minus 7 is greater than or equals to 0, x is greater than or equals to 7 over 2. X plus 1 is greater than 0, x is greater than negative 1. Take note, there is no equal sign at the inequality symbol. When x minus 2 is greater than 0, x is greater than 2. So x cannot be equal to negative 1 or x cannot be equal to 2 as the factors x plus 1 and x minus 2 are at the denominator. So let us draw the number line. For x greater than or equal to 7 over 2, so it is represented by a solid line, whereas the tail is negative. For x is greater than 2, for x is greater than negative 1. So for the interval less than negative 1, negative. From negative 1 to 2, it is positive. From 2 to 7 over 2, it is negative. And more than 7 over 2, it is positive. Since the inequality sign is greater than or equals to 0, the intervals with the positive sign are selected. So the solution will be negative 1 to 2 union 7 over 2 to infinity. Example number 4. In this example, we are going to use the table of signs method to solve this inequality. Find the values of x for which x squared minus 12 over x is greater than negative 1. Bringing negative 1 over to the left hand side, simplify, and then we factorize the quadratic expression at the numerator. This is the end result of the simplification. So take note that do not cross multiply because x may be positive or negative. So the critical numbers for this will be negative 4, 0 and 3. We draw the table for this table of sign. -4, 0, and 3 are the three critical numbers. There are 4 intervals. On the left hand side, we are going to list all the factors x plus 4, x, and x minus 3. Let us put any number in the intervals. Let's say -5 is a chosen number for this interval, -2 is a chosen number for this interval, and 1 is the chosen number for this interval, and 4 for this interval. By substituting -5 into all the factors, we will get the signs. For example, -5 plus 4 equals to -1. -5 is a negative sign there. -5 minus 3, -8 is a negative sign there. Similarly, we can substitute all these numbers into all the factors. Lastly, f of x equals to x plus 4 times x minus 3 divided by x. We are going to use the sign negative, divide by negative, times negative will give us a negative sign. Similarly, we have positive here, we have negative here, and we have positive here. The intervals with the positive signs are selected as the inequality symbol is greater than 0. Hence, the solution is x is greater than -4 and less than 0, or x is greater than 3. You can try these exercises for rational inequalities.